So good morning, class. Today I want us to look at the topic of matrices, a Form 3 topic. In real life situations, we have been taught some of these concepts that we are going to meet here. And which are these concepts? For one, we are going to look at addition. See also what multiplication is. Subtraction. The rows and the columns. So we are also going to look at the rows and also we are going to look at the columns. And we are going to look at the information arranged horizontally, and that is for the rows. So we are going to look at left to right. That should be very key. We are also going to look at what columns entails. Arrangement in vertical. And in vertical it means that it must be from top to bottom. So vertical, from top to bottom. But for matrices, it is all defined by rows and columns. So in this case, we have examples of matrices, and actually we are going to give just an example that is going to help us understand what a matrix is. So we'll have an example of a matrix A, B, and C, D. That's a very good example of a matrix that we can have. Now in this matrix, we have rows and also we have columns. So we have rows and columns. So we need to first of all identify what our row is. And we have two rows here, if you check very closely, because we have A and C are horizontal. And then if you look at B and D are also horizontal. What that tells us is that we have two rows here. And the first row is this one. This is our first row. And we have our second row, which is made by B and D. So that is our second row. Again, because we have said a matrix is defined by rows and columns, then we need to look at what our columns are. Now, since we have said our first row is this one and our second row is this one, we need to identify columns now. If we come here and say what are our columns, we have that are arranged vertically, A and B. So A and B. That one gives us our first column. Our second column will be given by, so our first column is this one. So our second column will be which one? Will be made by C and D, those two. Now, in matrices, those variables there, or those letters, are known as elements. So we have the elements in our matrix. So A, B, C, and D are what we call elements. So elements of a matrix, or what makes a matrix, they are these elements. They could be values, they could be variables, or letters or symbols. What defines a matrix? So a matrix is defined by rows and columns. So a matrix is defined by rows and columns. So for this one, we can have so it is defined by rows by columns. Now I want us to look at the types of matrices. Types of matrices. We look at the rows and the columns that makes that matrix. That is one thing. The second thing is we make sure, so we look at the rows and the columns in that matrix. So that is very important, the rows and the columns. The second thing that we are going to, or that is going to help us understand the types of matrices, is the elements in the matrix. So we have also to look at the elements of a matrix. So that is very key when we are determining the types of matrices. So the first matrix is one, what we refer to as the row matrix. So we have a row matrix. So it has only one row. So has only one row. Then we have another matrix. We look at the column again. So we look at the column, and that one will be a column matrix. So has only one column. So a row matrix has only one row. A column matrix has only one column. Other types of matrices. And now the matrix number 3 is what we call a square matrix. We need to understand that it is referred to as n by n matrix. In other words, we want to say that the number of rows equals the number of columns in that matrix. So the number of rows and the number of columns are equal. Very good example is this matrix A, which is given by 2 rows and 2 columns. So like in our case, A is a 2 by 2 matrix. And in this case, a 2 by 2 matrix is what type of a matrix? Is a square matrix. We can still have a 3 by 3 matrix, which is also a square matrix. Another type of a matrix, and this type of a matrix is referred to as, that is number 4, an identity matrix. An identity matrix. For this matrix, we normally look at the elements. Here we look at the elements. Just to bring you back to a matrix or a table, because a matrix is from a table, we should know that a table has diagonals. So, as well as a matrix, which is a table consisting of information. So we have diagonals, and in those diagonals we have the information. So the information, like in our case, we have A and D, then B and C. Those are the diagonals we are talking about. Okay, and in those diagonals we have the elements. So A is an element, B is an element, C is an element, and D is an element. Look at the first diagonal. Okay, and for this diagonal, we normally refer to it as the leading diagonal. So we look at the leading diagonal information. And again, we look at the other diagonal, which is the secondary diagonal. So So we look at the secondary diagonal. For an identity matrix, that is for a 2 by 2 matrix, you'll find that for the leading diagonal, a 2 by 2 matrix, for the leading diagonal, it comprises of 1. So we have 1 as a value. For the secondary diagonal, we have 0. That is for a 2 by 2 matrix, of which it's not the case for a 3 by 3 matrix, because an identity matrix will always be brought in by a square matrix. So if you understand a square matrix, you are able to understand an identity matrix. So for an identity matrix, we look at a square matrix. The leading diagonal comprises of 1s. The rest of the elements, we can talk of the rest of the elements here. Rest of the elements are zeros. So you make sure that the rest of the elements are zeros. So we have an identity matrix. So an identity matrix has something unique, and that is about the multiplication. When it comes to the multiplication of this matrix with another matrix, it does not alter that matrix. What do I mean? This is what I mean, that identity matrix multiplied by a matrix, a certain matrix, is equivalent to that matrix. So it does not change, or it does not alter that matrix. The original matrix remains to be the same. This could also be written as A multiplied by I, which is equivalent to A. So in any way, whether the identity matrix precedes the original matrix in multiplication, or whether the identity matrix succeeds the original matrix in multiplication, it does not alter that matrix. And that is what we need to understand, the uniqueness in identity matrix. So something very unique also we need to understand. I know we have looked at squares, we have looked at rectangles. What determines a square is its diagonals. What determines a rectangle is its diagonals. And very interesting is that for a matrix, it is always determined by the diagonal information or elements in that matrix, a determinant of a matrix. Determinant of a matrix. So I want us to look at that, very important. So what is a determinant of a matrix? For one, we need to understand about the diagonals, okay? And in diagonals, we have what we call the leading diagonal and also the secondary diagonal. So we have the leading diagonal and we have the secondary diagonal. In our matrix that we have there, which is a 2 by 2 matrix, which had 2 rows and 2 columns. And actually for a determinant, it actually applies for a square matrix, a 2 by 2 matrix. We have the leading diagonal, made of which element? Element A and element D. So we have A and D. Then for the other one, that is for the secondary diagonal, we have B and C. So we have B and C. What's very interesting with this, it is taking us back to multiplication and also subtraction. So look at those elements in both of these diagonals. We have A and D. So we multiply the two. So we will have here A multiplied by D. Okay? Then we will have here B multiplied by C. And what do we do to these ones? We subtract the two. So for a determinant, it will be AD minus BC. Now, I want us also to look at what we call a null matrix. So our number 6, null matrix. What is a null matrix? From the word go, null means 0. So a 0 matrix, that is what we have. So what about a 0 matrix? All the elements of which, like A, B, C, and D, are all zeros. So all the elements are zeros. And then we have what we call a singular matrix. That is our number 7. Singular matrix. And for a singular matrix, although this one we will go into details sometimes later after this video, we will find that a singular matrix is one with no inverse. Determinant here is equivalent to 0. Before we end our session today, I know it has been a long session, but a very interesting session, because for one, we have known about matrices. We didn't expect to see a matrix in another dimension, like in the dimension of a table. A table which has got rows and columns. Like we have the information in those rows and in those columns. That is something very interesting that maybe we did not expect in this topic. Another thing that we did not expect in this topic is to learn about the information in a table. It could be represented in terms of values or variables. Now, those values or variables or letters that are in that table or matrix, we refer to them as elements. So very key, we have the elements there. We have talked of the rows, we have talked of the columns, and for rows and columns, just to insist on that, we need to understand that for rows, you have to look from left to right. Then for columns, it is from top to bottom. In this topic, remember, it's very simple. We are going to have addition of matrices. We are going to have multiplication of matrices. And we are going to have subtraction of matrices. We all know how to add. We all know how to subtract. We all know how to multiply. But in matrices, we have to learn the techniques of multiplying matrices. So that marks the end of our topic today. So thank you and welcome back to our continuation in the next video. So welcome and thank you. Bye bye.